It should be no surprise to any logical person that climate change is a real threat to our planet's biodiversity, ecology, agriculture, infrastructure, and society. Even in the present day, climate change is responsible for anywhere from 250,000 to 5 million casualties globally every year. Since the year 1900, Earth's average temperature has risen by a full degree, and sea levels have risen 21 centimetres or 8 inches. Even in the present day, climate change is responsible for anywhere from 250,000 to. There have also been over 500 confirmed vertebrate extinctions since the year 1500, and there's likely been thousands upon thousands more that we don't know about yet, plus many extinct animals that haven't quite been declared extinct. So, how will these statistics change by the year 2100? What will the planet's biodiversity, ecology, and climatic composition look like in 75 years? The reason I've chosen the year 2100 is because there's a lot of statistics that focus on this year regarding climate and biodiversity. Although slightly arbitrary, as I could have picked 2099 or 2101 and the setting would be near identical, 2100 will be a milestone, being the start of a new century, so I'm picking it. Probably the most obvious place to start in a video like this is with the climate of the year 2100. With the continued consumption of fossil fuels and the greenhouse gases emitted from their use, Earth may experience a significant rise in temperature in the coming decades. When sunlight enters the atmosphere of the Earth, the greenhouse gases trap some of the heat that would usually escape back into space. This in turn causes the ocean, surface, and atmosphere of Earth to rise in temperature, creating a planet known as a greenhouse Earth. The UN has predicted time and time again that Earth will likely hit 1.5 degrees warmer than pre industrial levels by the 2040s or 50s if there is no change to current climate policies. However, the 1.5 degrees Celsius threshold was actually breached in 2024 with the average surface temperature of 1.54 degrees Celsius above normal temperatures, with an error range of 0.13 degrees Celsius. Earth's temperature will likely exceed 2 degrees as early as the 2030s and 3 degrees possibly as early as 2050, though 2100 may be a more probable date for 3 degrees. There have also been predictions of Earth exceeding 4 degrees by 2100, though these may not be very realistic, as they are slightly outdated estimates that don't account for potential future climate policies. Anyway, with an increase in temperature, ice caps globally will continue to melt. It was predicted in 2023 that if Earth rose 1.5 degrees Celsius in temperature, that over a quarter of summer ice sheets would melt. Meanwhile, if Earth was 4 degrees warmer, over half of year round sea ice would likely melt, leading to a rise in sea levels of up to 15 centimetres, respectively. Other estimates for the sea level rise by 2100 range from 20 centimetres to as much as 1.6 metres above pre industrial sea levels. Even a rise of 15 centimetres in sea levels would cause major flooding in low lying coastal areas, such as several cities in the Netherlands, Australia, India, and the United States, which will all suffer major losses in both population and the economy. This isn't even to mention entire countries like Bangladesh, the Solomon Islands, Tuvalu, or the Maldives, all of which may completely disappear within the 21st century, which could replace millions of people. As a matter of fact, sea level rise by 2100 may lead to up to 100 million people becoming replaced and homeless, which would in turn have to lead to mass migrations among people everywhere on Earth. Not only will the mean sea level be different, but also the oceanic pH, which may drop all the way down to 7.8. a decline of 0.3 pH from today's levels of 8.1. If oceanic pH drops to 7.8 by 2100, an estimated third of marine species may go extinct, including countless shelled animals such as snails, clams, and crustaceans. The average proportion of atmospheric carbon dioxide is another element to consider when listing changes throughout the century. Today, the carbon dioxide concentration in the atmosphere is an estimated 422.03 parts per million, or ppm. For some comparison, the concentration of CO2 at the end of World War II in 1945 was an estimated 310.3. So that's a rise of 111.73 parts per million in just 80 years. By the year 2100, it's possible that at the current rise of 2.8 parts per million per year, that the global concentration of CO2 may rise to 630 parts per million, which is a rise of over 125% from the pre-industrial levels of 280 parts per million, or even less. Then there's desertification, which is an indirectly man-made phenomenon where deserts expand via sand and dust storms. This usually happens when compaction in the soil is not maintained, and the result is increased erosion and weakening of topsoil. Areas in southern Europe, such as Turkey, Spain, and Portugal, are at an extreme risk of desertification and risk becoming completely desertified by the year 2100. As a result, we can expect to see climates and ecosystems similar to the Tabanas Desert becoming more commonplace in these countries. Now let's move from talking about climate change and now turn to focus on the extinction rates of the year 2100. It is estimated that anywhere from 180,000 to over 1 million species could be extinct by 2100, which would mean a decline of anywhere from 2% of species to over 50% of species, depending on the source. Unfortunately, these include many charismatic megafaunal species such as elephants, big cats, and great apes. Every year, an estimated 70,000 African elephants, 3,000 great apes, 600 lions, and 150 tigers are killed for their body parts, which are often taken to the black market, and this is alongside them being killed for sport or taken to the pet trade. There is also a decreasing trend in the Sumatran and Javan rhinoceros populations, with both species having a high risk of extinction by the year 2030. 2100 will almost certainly be a very megafaunally impoverished time, with the largest land animals remaining being those with increasing population trends today, such as the African rhinoceros species and the Indian rhinoceros. In addition, many large animals that are in danger of extinction within the next 30 years alone serve major roles ecologically speaking. After all, elephants, most shark species, lions, tigers, sunder rhinoceros, giraffes, and great apes all serve crucial ecological roles, and if they go extinct by 2050, our lives will only be made worse. However, it's not just large vertebrate species with decreasing populations, as insects such as bees, butterflies, and beetles have experienced annual declines of 2%. And as a result, they could become extinct before 2100. Without pollinating insects, many fruits, vegetables, crops, and nuts might no longer be pollinated with much frequency and would go extinct in a short period of time. The probable extinction of most bat species by 2060 would further seal the deal for many floral species, leading to the prices of many foods skyrocketing, potentially leading to a rise in poverty and widespread starvation among people. These are only some of the statistics on the planet's ecology, climate, and environment in the year 2100, and there's plenty more, such as the loss of the Amazon rainforest and the Australian Great Barrier Reef. So, what can we do to change this mostly negative future into a positive one for future generations? I mentioned in a previous video that creating more national parks would help mitigate biodiversity loss. By protecting species from human advancements such as urbanization and poaching. While this is definitely a good solution, it will not be effective unless a large area of land globally is converted into national parks. Another method that might help mitigate current environmental problems is creating thermally passive buildings, which can be done in multiple ways. Now, I'm definitely no architect and not really qualified to talk about this subject, but in short, a thermally passive house is a house design that incorporates various elements of architecture, which helps minimize the need for electric heating and cooling. If hypothetically every house built in the future was thermally passive, then it would reduce the need for electricity in the summer and winter. And as a result, it would save plenty of electricity and would help us reduce our carbon footprint as a species. If Earth was to reduce carbon dioxide emissions by 45% by the year 2030 and reach net zero by 2050, then we will see global temperature rise be limited to 1.5 degrees Celsius above pre industrial levels, which should be the aim to avoid the point of no return. If Earth if we can cut emissions and limit global warming to 1.5 degrees, countless species, including those from polar latitudes, will likely survive for countless more generations. Plus, millions of people would no longer be replaced from their homes in flash floods or monsoons. However, if we don't curb emissions and let temperatures rise to 3 degrees and higher by the end of the century, then we would be living in a real life dystopian civilization, not dissimilar to those found in fictional settings and third world countries.